Alright, so we're going to bring some geometry into this, and the reason is because this geometry uses proportions in order to solve. So we need to talk about what similar figures are. And so similar figures are shapes that have the same shape but not necessarily the same size. So like in this example, we have two triangles. They are both the same type of triangle. They have congruent angles, but their side lengths are proportional. So what that means is like angle A is, we call this congruent to, which just basically means equal. But in geometry, when we're talking just solely shapes, we're going to say congruent to. So angle A is congruent to angle F. Angle B is congruent to angle G. And angle C is congruent to angle H. And so from here, as long as my angles are congruent, then my side lengths are proportional. And so I would know that side AB over FG. And then that would be equal to BC. So here's BC over GH. So it's one side from each triangle in each of these fractions. Finally, CA with HF. So I could write this as 8 over 12, and that should be equal to 12 over 18, which should be equal to 10 over 15. And so if we were to simplify each of these, this first one, 4 goes into it, and we're left with 2 over 3. 6 goes into this next one. 6 goes into 12 and 18. So 12 divided by 6 is 2. 18 divided by 6 is 3. And 5 goes into this last one. 10 divided by 5 is 2. And 15 divided by 5 is 3. And this is why they are proportional. Notice that they all simplified down to the same fraction. So the same ratio. And that's what we want. All right. So how do we find the length of DE? So first figure out where DE is. So here's DE. That's my question mark, right? From there, I only need to be worried about side lengths that are on the same, like I can't pair AB with DF or EF because they're not in the same position. So the only one where we're in the same position is BC with EF. And so that's what I'm going to start with. 16 over 12. And that's going to be equal to, now, DE would be in the same position as AB. And so I'm going to do, since I did the 16 on top, that means I have to put my 10 on top with my DE unknown on bottom. From here, I'm going to cross multiply. So 16 times x is 16x. 12 times 10 is 120. And then we solve. So I'm going to divide both sides by 16 in this case, because that's how we'll solve this equation. And I end up with 7.5. So the length of DE, so DE will equal 7.5. And that's our answer. All right. Now we get into some like real world like problems. The sun's rays strike the building and a girl at the same angle, forming two similar triangles shown. How tall is the building? So looking at the image, this is what I know. I know that the person is 5 foot tall and their shadow is 3 feet. And I know that the shadow of the building is 15 feet, and I want to know how tall the building is. So I'm going to do my shadow on top, my person on bottom. So then I'm going to put my shadow on top and my height of the building on bottom. So again, it's just all about making sure, and we have triangles here. So I'm making sure these are the same, one from each, Silly Mrs. Cartwright. I set up my equation wrong. I want one from each side. So I'm going to do 3 feet with the 15 feet. Those are my shadows. Shadow with shadow is equal to the 3 feet is with the lady. And so her height 5 feet over my unknown, which is x. From here, we're going to cross multiply. We end up with 3x equals 15 times 5. 15 times 5 is 75. Right? So again, I went corresponding sides of the triangle need to be in the same fraction. So now I solve. So I'm going to divide each by 3. So then x is 25. So it is a 25-foot building. Sorry for any confusion there. Mrs. Cartwright had a brain fart. And that happens. The reason I left it, you need to know I make mistakes also. But again, the correct way to set it up, shadow with shadow is one fraction because those are the same side of the triangle. And then height with height as your other fraction because, again, those are our same sides of the triangle. All right. I believe last example. Yep, last example. A giant model heart is shown below. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of the man who is 6 feet tall to be? So we're going to do heart with heart. So I don't know the size of the heart in the person, but I do know that this one is a big giant heart at 14 feet. I'm going to, so small, big. So now I need the person's height on top and the unrealistic height of a person on bottom. So that we are doing heart with heart, heart with heart, human size with human size. All right, so from here, cross multiply. So I'm going to do 14 times 6. And I'm going to get 84. And I'm going to take 170 times x, so I get 170. X equals 84. And then we're going to divide both sides by 170. And so then x is going to be approximately, I'm going to change that from equals to approximate. Actually, that looks terrible. X is approximately 0.49 feet. And I had to round, so that's why I say approximately 0.49 feet. So about half a foot is the size of a heart inside a 6-foot man. All right, so again, we did heart with heart, human size with human height, even though that one's really unrealistic, but really it's because the model is one of those like walkthrough model type things. So that's why it's unrealistic size. I hope that we now have an understanding of similar figures. This one didn't really have us pull in triangles, but it was shape with shape. So I guess that's how they're fitting that one into that. Who knows? I will see you in class. Peace out.